Hello guys, welcome all. I'm your host none other than Deko Mohammed. Today's focus is on net present value of an annuity. We want to see how to calculate the net present value of an annuity. For this case, annuity means a fixed cash flow, a cash flow that is constant. If it is 10,000, that is for year 1, year 2, 10,000, year 3, 10,000. It is constant. Now we want to see how do we calculate such kind of cash flow. Let me open the whiteboard and consider a simple illustration. We want to consider a simple illustration. Now, let's say want to see this. Let us consider a project. Want to consider a project. Let's consider a project with a cash annuity of 50,000, let's say 100,000, with a period of 5 years. Period of 5 years. Then the cost of capital, is 5%. The cost of capital is 5%, and the outflow and the cash outflow is 300,000. Now we will consider a project with a cash annuity of 100,000. For this case means 100,000 is constant throughout for the 5 years. With a period of 5 years, the cost of capital is 5%, and the cash outflow is 300,000. Now required calculate the NPV. Now remember, the simplest formula for NBV is equal to the present value cash inflow. PVCIF stands for present value cash inflow. Then subtract this from the present value cash outflow. But for an annuity, remember for our case here, before I go to annuity, if you could have said it is PIVCIF minus 300,000, because we already know we have given the outflow is 300,000. Now the interest here is to calculate the present value cash inflow. So for an annuity, the present value cash inflow is equal to take the annuity, this annuity multiplied with the present value interest factor of an annuity. we take the annuity multiplied with the present value interest factor. That would give us the present value cash inflow. Now, we already know the annuity is 100,000. For our case, it is 100,000. 100,000 multiplied with the PVCIFA. But we don't know the present value cash inflow annuity. There are two ways of getting the present value. There are two ways of getting the present value interest factor annuity. Let's consider the first approach. Let's consider the first approach. Now, the first approach is we take 1 minus, we take 1 minus, then open the bracket, take 1 plus R, then close the bracket. Then this we raise to negative n. We raise this to negative n. For our case, our n is 5 years, so we have to raise to negative 5. Then this divide with R. Divide this with R. Now, if we calculate this, we are going to get the present value cash inflow, present value interest factor. Present value, this should be present value interest factor, not cash inflow. So we need to get, if we sort out this, we'll get the present value interest factor of an annuity. Now, let's start. We have 1 minus, then I open the bracket. 1 is 1, then I add, our R here is 5%. Cost of capital was 5%, so we take 0.5% is 5 over 100, which is 0.05. Then you close the bracket. You raise to negative n. Negative n means negative 5. Our n was 5 years, so we raise this to negative 5. Then divide this with the R. Our R was 0.05. 0.05. Now, if you work out this, you are going to get the present value interest factor of an annuity. So that we multiply that with the annuity, then we get the present value cash inflow. Now, if we work out this, we'll have 1 minus 1 plus 0.05 is 1.05. If you take 1 plus 0.05, it is 1.05. Now, we'll have 1 minus 1.05, but this one will be raised to negative 5. Will be raised to negative 5. Now let me have a bracket so that at least we know 1.05. This one is raised to negative 5. Then we divide this with 0.05. Now, first, let's take your calculator, write 1.05, raise. Remember, raised is the one that looks like the triangle horizontal, which is the near x squared. From your calculator, you will have that is raised to. Now, you click on raised to negative 5. From my calculator, if I take 1.05 raised to negative 5, I get 0.7835. Remember, I just solved only 1 plus 0.05 raised to negative 5. I have not done anything else yet. So I'll have 1 minus. If I take 1.05 raised to negative 5, I will get 1 minus 0.7835 to the nearest 4 decimal places. I hope you get the same answer, 0.7835. Then divide this with 0.05. So let's now do it together. We take, remember, 1 minus 0.7835, you get 0.2165. Then this divided with 0.05. If you sort out this, it will give you the answer here. If you take divided by 0.05, it gives you 4.33. 4.33. If you take 0.2165 divided by 0.05, you get 4.33. Now that is our present value interest factor. Our present value interest factor. Now we need to multiply this with the annuity so that we get the present value cash inflow. Now remember that present value interest, present value cash inflow is equal to the annuity. In our case, the annuity was 100,000. Is equal to 100,000, which was the annuity. Then multiply this with, multiply it with a take multiplication, multiply it with 4.33. Now, which will give us how much? Times 100,000. This will give us 433,000. This is the present value cash inflow. Now, the second approach of getting the present value cash inflow, let's consider the second approach. Second approach. Now, second approach, we take one, subtract it from, open a bracket, take 1, divide this with 1 plus r, 1 plus r, 1 plus r, close the bracket, then raise to n. We raise this to n. We raise this to n. Then we divide it with 0. We divide also with r. You take 1 minus, then take 1 over 1 plus r raised to n. Then divide all of it with r. First, it is 1 minus. We start with 1 over 1 plus r. Let's solve the bracket first. Remember, our r was 5%, which is 0.5 divided by 100 is 0.05. If I take 1 plus 0.05, I will get 1.05. Now, this will give us 1 minus. If I solve 1 plus r, it is 1 plus 0.05. Then let me raise to 5 because our n is 5. I get 1.276. So it is 1. I take 1. Divide this with. Remember, I only solve 1 plus r raised to n, which I said 1 plus 0.05 raised to 5. You get 1.2. Sorry, 1.276. 1.2763. 1.2763. I only solve 1 plus r raised to n. Now, then we divide this with r. Our r was 0.05. 0.05. Now, let us solve first 1 divided by 1.273. Then subtract that from 1, then we divide the 0.05. Now, let me take 1 divided by the 1.27628. 2763. 1.2763. I get 0.7835. Now this means I take 1 minus 0.7835. 0.7835. Now, remember, then we divide this with 0.05. Remember, when you're using the, let me show you. Remember, when we were using the first approach, this is where, if I check, you see this is what we had on the same case with this. 1 minus 0.78, the same case we have here. Obviously, now this will lead us to the same answer, which will give us, this now obviously will give us equal to 4. This will give us 4.3. 4.33. Now, remember, I said NBV is equal to the net present value cash inflow. Subtract this from the present value cash inflow. Subtract it from the present value cash outflow. But for an annuity, the present value cash inflow is equal to the annuity times the present value interest factor. Now, I said there are 2 approaches of getting the present value interest factor. We consider the first approach, whereby we say it is 1 minus 1 plus r minus 1 plus r raised to negative n. Then divide this with r. You get the same answer. Now, remember, when you multiplied 4.33 with 100,000, this was our this was our amount, 403,000. Now we need to get the NBV. We need to get the NBV. I need to get the NBV. Remember, I said NBV is equal to present value cash inflow. Subtract this from the present value cash outflow. Remember, in the question, we have been given the present value cash outflow, and we calculated the present value cash outflow as 433,000. 433,000. Then subtract this from, subtract it from the question we have been given. It is 300,000. That was the present value cash outflow. 403 it is what which we just calculated. Then subtract it from 300,000. Now you get the NBV. Now, which for NBV is equal to, we take 433 minus 300. which is 133,000. 133,000. Now, remember, this is now our NBV. And when we say it, this was our NBV, which we say present value cash inflow minus present value cash outflow, of which it is now 433 subtracted from 300, which is 103,000. This is a positive NBV, and a positive NBV we have to accept. Now, that was the class on net present value of an annuity. In our next class, we want to see what about the one without an annuity, where we don't have a constant cash flow. We have different cash flow. Stay tuned and you will never ever regret. Then check more on this channel of mine, Deco Mohammed. Subscribe, like, and share with your friends. Thank you for watching.